Hi, and welcome to a brand new video. In this video, we're going to be talking about formal charges. And if you go on the internet, you're going to find mathematical formulas, and it's going to be super confusing. But in this video, I'm going to be sharing with you a much simpler method of formal charges. And hopefully, this makes your chemistry life a lot more easier. So first, let's just go ahead and try this example on the board just to kind of refresh your memory. So if we have sulfite, remember the ite means one less oxygen. So it's either going to be the 2-3 pair or the 3-4 pair. So ite means it's one of these two. And since sulfur, I talked about this in one of my previous videos, is that inside 7 is going to be over here 3 oxygen. So it's going to be SO3 2 minus. And if you want to know how exactly I got that, then go ahead and watch that video. But in order to draw the structure, well, you might be like, well, first we're going to draw sulfur. Sulfur has 6 valence electrons, so 1, 2, 3, 4, 5, 6. And then we're going to go ahead and draw oxygen in, so that'd be 1, 2, 3, 4, 5, 6. And then another oxygen, 1, 2, 3, 4, 5, 6. And then you can just add in those 2 electrons right over here. We perfectly have 2 of our 3 oxygens. But we still have, my bad, we still have one more that we had to add in. So the first method that we could just do right over here is that we could just double bond this. So we can go ahead and we can just double bond it. And in this case, these electrons, it wouldn't be up and down, it would be diagonal because it would try to repel as much as possible. So in this scenario, we have a dash dash. This over here would be a single dash, this would be a dash, and this would be our Lewis dash structure. I'll go ahead and fix those lines real quick. The reason this is allowed is because sulfur has a d subshell, which means it can have more than 8 electrons because those extra electrons will go into that d subshell. So let's just count electrons. We have 8 here, we have 8 here, we have 8 here, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here. And then we'd have to go ahead and put those brackets around it. And then you have to put that charge. But if you've learned about dative structures before, or otherwise known as coordinate covalent bonding, you've probably, once you get to this stage right over here, you might realize, wait, there is another way to bond this, and yes, there is. You can use a dative bond. So in a dative bond, basically what happens is that instead of them sharing one electron each, sulfur shares both of its electrons. So right here, these 2 electrons come from sulfur. So this is sulfur, and this is what we call a coordinate bond, or in some older textbooks, you'd see the dative bond. And we'd still draw it kind of like a dash structure here, but you can notice that both of these work out, and they work out quite well. So in order to kind of see which one's right in the scenario, we have to use something called formal charges. And that's what we're going to be learning about how to do in this video. So in order to do a formal charge, what you're first going to do is you're going to kind of cut these bonds in half. And you're going to just put electrons at the end of these bonds, that's just a little bit easier to count. And you're going to go ahead and do these in both structures. The next thing you're going to want to do is just count up the electrons in each of the atoms. Even if you're doing a coordinate covalent bonding, as you can see right over here, you're still going to pretend like one came from each of the atoms. So how many electrons are in each of these atoms? Well, just count. So here we have 7. We have 7. We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we have 7, 7, 6, 6. While over here we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Oh, sorry, my bad. This is 7. 1, 2, 3, 4, 5. And this is 1, 2, 3, 4, 5, 6, 7. So what you're going to have to do now is you're going to say, well, which one of these structures is better using this information? So there's one more step you're going to have to do in order to deduce this. You basically need to find out, well, how much charge each atom has. Well, oxygen, it normally has 6 valence electrons. That's what sulfur and oxygen normally have. But in this scenario, it has 7, so that means it has a charge of -1, one more electron. Sulfur is fine, this other oxygen fine. Same scenario here, it has one more electron than it should have, so it's a -1 charge. Here, same thing, same thing, same thing. While this 5, it has one less electron than it should. Remember, right, it's supposed to have 6, it has 5, so it's going to be a +1 charge. So the first thing you need to make sure is that in all of these examples, the charge adds to the charge that was given in the problem. So we have a 2 minus charge, and yep, both of them add up to 2 minus. We also need to make sure that we did everything right, which we sure did. And now in this case, we have two ways to deduce whether or not these are right. So the first way is to look at the electronegativity. And basically, the electronegativity is saying which, the charge is more likely to be on the the electronegative element. So that means that the charge is more likely to be on like the oxygen than it is on the sulfur. The next condition is that the charges are most of the time -1, 0, or 1. So if you have a +2, which doesn't apply here, that means that's typically not going to be the structure. And the third thing, which is what we're going to be using here, is that whichever has more neutral charges. Because adding more or less electrons is going to be less natural. So you can see here on the left-hand side, my bad, we have 2 neutral charges, while on the right-hand side, we have 0. So that means that this structure right over here is going to be more likely. So I hope this video was helpful, introduced to you the idea of formal charges, and see you in the next video.